Hello, hello, hello. Alright, play music. Hello, 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 hello. Test all the audio. Test all the audio. Hello, 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 hello. Okay, that's fine. Okay. Whoa, whoa, whoa. No more. Alright, typing test. I hate how my typing like always like it sounds like I'm punching a hole through my thing, my desk, but I'm not. But whatever. Okay, so unlike the last stream where I practiced the day I didn't stream, I did not practice yesterday. Yesterday was my break day, but whatever. We're gonna now here's the actual game plan for this stream. Is this paused? No, pause that. Oh, and let me turn back on the music. It's a little bit too much for me right now. Okay, so here's the game plan for this stream. We're gonna do the daily, which this is a really easy daily. So, and I've done it like, how many times have I done this question? 4 times over the last almost year. So this is a really easy question. So I'm gonna get this one out of the way. We're gonna do a couple warm-up questions. Unlike last time, we're not gonna spend 4 hours on it. This practice is gonna be around 3 hours, I think. I'm gonna shoot for a 3-hour stream sesh, and then take a break, and then practice off stream for a little bit so I can focus a little harder. Because I caught myself last time reading chat a lot. Well, my friend was in there who's like basically my coach, so like we were kind of working through things together. So I don't really consider that counting. But if people do come into the stream and I'm like chat having conversation, I'm not totally locked in, you know, that's why I like doing off stream practices and stuff. And I'm allowed to be, I feel like I'm a little bit more comfortable off stream, but yeah, so the game plan is do some LeetCode problems, and we'll tackle some CSCS. We're probably going to do some sorting and searching questions because those are important fundamentals to practice. And yeah, I wish like for this current month, for the rest of this month, and probably next month, we're going to be really focusing on getting these fundamentals down pat. So yeah. Alright, let's get this done. We also need to work on implementation, but that's fine. I'll see. CNX. Previous. Let's see. First try, baby. First try. I got reversing linked list down pat. Ain't if that question ever comes up, it's over. Alright, let's do some warm-ups. That daily was stupid. These dailies having, you'll see like the dailies, they'll become like a waste of time. You know? There'll be like really easy problems, and it's just like kind of like, damn. Like, why am I doing this? Alright, what do I want to do? Add binary? I hate doing carries. I hate doing any carry. Combinations of backtracking? Yeah, let's do a backtracking problem real quick. That'd be fun. This seems like a not too hard backtracking problem. I suck at backtracking, by the way. The day I become good at backtracking will be the day I die, probably. I will never be good at backtracking, but whatever. Alright, let's learn. Alright, before I just jump into this problem, let's learn about the lesson we learned last stream. Let's actually read problems, you know? Okay, this music is a little bit too much for me personally. Let me just turn down my headset volume. Okay, there you go. That's more nice. Let's actually read the problem. So, from what I'm saying, you're given a range, boom, that's important, of k possible combinations. So that's basically, you're given basically an n, so if n is equal to 4, you're given 1, 2, 3, 4. And then you're given k, which k is basically the length of that combination. So like, instead of like, in like subsets that you'd like have an empty set, then you'd have 1, you would have 2, you would have 3, you would have 4, and then you would go to like, you just ignore my trash drawing, and then you would have like 1, 2, and then blah blah blah. This one only wants like the kth subset, right? Which in my opinion makes this probably, I think this makes this a little bit easier. So we're gonna have this, so we're just gonna use this example of 4 and then k. So the way our backtracker is gonna work is we'll have this, we'll have like an empty array, and then in our decision, the way I like doing, if anyone knows the correct way to do backtracking, the way I like to do backtracking is I like to think of like the decision tree, and like backtracking is like you can choose one path or the other, and like sometimes you'll have 3 paths, but like it's just a decision you have to make. I mean, that's what it is a decision tree. So I always like to structure my backtracking based off like decisions, like to sketch it out. So for my decision, there's gonna be 2. We'll have an I. You'll have an empty subset at the start, and you can either choose to add I, or you can choose to skip and increment I and not add it, and then just keep it blank. So your left option's to add it, your right option's to not. And what's gonna happen is the break case is if like the length of our current subset is greater than k, or if it's greater than or equal to k, break out. So here we'll increment I, not do anything. This would be 1. Here this would be 1 and 2, while this would just be 1, but remember I still gets incremented here. So then this would just be 1 and 3. This would be 1. And then obviously keep going. And we only want to print when this is the case. So I think this would work. And just don't print if there's an empty. Don't ever print if it's greater than. If the length, like the length of this is less than k. Like only print if length, of cur is equal to k. That's only when you want to print, because this will protect from like empty subsets, one subset, and bigger subsets than k. Like, and this decision tree should work out. And you can tell that we can backtrack it because it's only 20. And backtracking is, I'm pretty sure, a 2 to the n operation. So since it's 20, you can, you know, do it. Because remember, an integer is 2 to the power 22, and you can process 9 seconds. I'm pretty sure this much. I don't know. I don't have those numbers down by heart, but whatever. So let's actually code this solution up. And we don't actually have to, we'll have to return this as an array, but for now, let me just create this, and then we'll have return res, but for now, I'm gonna print it out, because I like to, since we're practicing, I don't really like take my time to understand everything. We have an I, we have a cur, and yeah. So if I is, and then we'll have like n, right? So if I is greater than or equal to n, return. If length of cur is equal to k, we're just gonna print cur and return. Else we're gonna run our 2 operations. So we're gonna say DFS I plus 1, I plus 1, and C we'll say c dot append I for I plus 1, and then we'll append c, and n doesn't need to be passed in because n is given here. And then we'll have c.pop, and then we can say dfs I plus 1 c. That should hopefully be all the cases covered. And let's see what happens. MG subsets. I'm in college. 1, 2, 1, 3, 2, 3. And then a none. Is that what we wanted? That is 1, 2, 1, 3. If it's greater than, try it. 1, 2, 1, 3, 1, 4, 2, 3, 2, 4, 3, 4. That looks right. That looks right. And then we have this none printing out. So why is this none printing out? I will just say C and this is the case to prevent that none from happening. Like 18 to 20 range. Like that's the around the age I'm at. What is this none printing out? Oh, because, yeah, that makes sense. Because I'm printing out the DFS. I don't need to print out the DFS because this is returning nothing. Thank you, bro. Good luck on your stuff too, bro. Alright, let's do this. Res.append cur.copy. And that's right. And there we go. Alright, easy backtrack down. So, let's do another one. Let's pop off another one. Right. Minimum path sum. This seems like a good problem. Oh, I don't know if I want to do this. I don't like number theory problems, and I don't like matrix problems or grid problems. There's two things I hate the most. I really like graph problems, and I really like tree problems, and I hate linked list problems. Those are the three problems I hate. For if anyone knows, if you ever want to send me a problem to try, don't send me a linked list problem, a number theory problem, or a matrix problem, and we'll be square. And I'll do it, or I'll try. May MXN grid fill with negative. Okay, so you have an MXN grid filled with non-negative numbers. Find a path from the top, the left to the bottom right, which minimizes the sum of all the numbers along its path. Okay, this is a nice, interesting one. Okay, so okay. So this is either this is like a DFS or a BFS solution. What am I returning? 7? I'm just returning a number. Okay. I could. Okay, so if I DFS this, the problem is I don't really want to run through every single possible solution because, at least in contest, that would be too slow. Because, say the worst case of this, 200, actually 200, what's 200 times 200? Oh, yeah, it's pretty big. Like 40,000? If I know how to do math? That's 40,000 possible combinations. Inside the grid, 40,000. If I loop through each one, it's O of 40,000. That could work. Or we could start from the solution. Because your goal is to take it from this to go to here, right? What is the way we can move? You can either move down or right at any time. So if I were to work backward, if I could start, I mean, I don't know if working backwards helps here, but if I were to work backwards here, I would start here, and we would just pick the min of this option. So I'd pick this one. Then we're here. So we can either go here or here. And like from these two paths, you can kind of pick. So I want to pick the min again. Or what I could do, I mean, this could kind of be like an A star maybe. Well, A star doesn't really work here. This is not an A star solution because, well, actually it kind of is, but whatever, that doesn't matter. 1 3 1 1 5 1 4 2 1. My general thing I like doing when I have like at least grid problems or something and I'm trying to work towards a goal of some, like it asks me like, oh, what's the path? Is this possible to reach from a starting point to the goal? I always kind of find myself working backwards. Like all the problems I've solved, I don't know if this is a good habit or not, but I'm just gonna share it. Is I always like start from the goal and try to work towards the start. To me, it's always easier to think about the solution and like kind of almost code up. So I'm gonna try that approach here. So we obviously want to go here and we want to end up here basically. So my idea for the algorithm is we can go up, like our only option is go up or to the left, because like you're gonna inverse it technically because you're starting from the bottom, like because here you can go down or this way, but I'm gonna inverse this so it's up or left. So we're gonna pick, so the current path right here is 1, so we're gonna pick the min of these two. Like if you were to add up, so this would be 3 and this would be 2. Like these are your current options. These are the weights. So you can go and then you're gonna obviously pick 2. So your next step is going to be, let's go here. And then you're gonna recalculate everything. Well, you already have this calculated, so you can recalculate this. So your current sum path is now 3 up here, because this is 2, 3. If they're both even, I'll have to think of an edge case. So I'd probably, if they're both even, I'd probably just pick the one with the lowest. Pick the one with the lowest like node cost. So we'll pick this one. No, I don't want to draw in that color. Sure, this one. So we picked this one, and now our current path, we're at 3. And then now if we calculate this, this is 6. Let me draw that better. This is a total of 6, right? So since this is greater than that, we're gonna pick this path. So now we go here. And now we calculate this again. So 4 plus 5, 6, 7. This is now 7. So since 6 is less than 7, we're gonna pick this path. And then you can see this leads us right to our goal. So we're automatically just gonna jump to it, I think. I think that's a smart approach. Yeah, because we're already crossing this path, so yeah, we'll just, since we're right next to our goal, we're just gonna hit it, and then that gives us this kind of path. Alright. That's it. That's right. That's right. So I think that algorithm is gonna work. So if I'm given, let's just do one more edge case. Let's try 1, 3, 3, 3, 1, 2, 1, 1, and then a 5, I guess. Start from here. Goal is here. Okay, so this first step is going to be 3. This second step is going to be 2. Pick this one. The next step is going to be 3. This is still 3. Pick the lowest node. This is now 4. This is 3. Pick this one. Oh, what I did not think about when I was drawing out this solution is that you can, at every point in time, you have this way and you have this way. Okay. Now that I know that, I'm just gonna rewrite this, and then we're gonna full send the solution, I think. I don't know how I forgot about that. Okay. This is the goal. This is the starting. So at this current point in time, you can either go up or right here. The cost of this would be 2. The cost of this would be, or this would be 3, and this would be, and the cost of this would be 2, right? Because you take, and this would be like C. So this would be the current cost of 2. This would be the current cost of 3. Pick the minimum one. So we're gonna go here now. Now from this node, you can calculate. You're gonna be, you can either go up or you can go left. So if you go left, which our current path sums to, this operation is going to be 7, and this is going to be 3. So here's like the current path you can take. You can do this one, you can do 3, 7, or you can do this one. So, and then we'll just kind of, I feel like we'll store this in a priority queue, right? So we'll store this in a priority queue and have it pick from the lowest cost. So, and then we'll just store in a priority queue, run the operation, keep going. Each object will have its own thing, and that should work. So, priority queue, the lowest one, kind of just keep going until you reach the goal. If you reach the goal, but one problem is, well, if you take the lowest cost, like path, though, whatever you reach to first should kind of be, it should kind of be the shortest path automatically. Because, by the way, I don't know, actually, is that true? I don't think so. Oh, you're welcome, dude. I'm on the grind, man. I'll be streaming a lot, so you can always come here. Because my thing is, like, I think this will work. I think. Let's try this grid, and let's see what happens with these rules. Another thing that I don't like that I do on accident is, like, when I'm, like, designing, when I'm, like, drawing out a solution of mine, is, like, I'll always, like, if I know the solution, I'll always kind of, like, as I explain it, accidentally forget about how my algorithm's working. And then it causes me to skip over steps and then be like, oh, like, crap, this doesn't actually work. Because I did that accidentally when I was explaining this solution. So, let's just do this one. 1, 2, 3, 4, 5, 6. Goal is to get from here. Why am I drawing that in orange? Here to here. So, your total sum is 6 at the start, right? There's 1, 2, 3, 4, 5, 3, 6, 7, yeah. So your total path is 6 at the start. I mean, we don't really have to calculate this right off the bat. We can always just add up the last part. But for now, it's 0 or whatever, I guess. So if you go up, you can either go up or left, right? So if I go up, the total cost is going to be 3. If I go to the left from this point, so if I go left, total cost is going to be 5. So let's go up. Now from here, I can't go up anymore. This doesn't work. So we can go only left. The total cost of this is going to be 5 though. But since they're both even, I'm going to take the cost of the lowest node. So I'm just going to pick the 2. So when I pick the 2, I move here. Now I have now since I'm here and I see that if I move left, I instantly hit my goal. And I can't move up anymore, right? This is an operation of 6, but it doesn't matter because we can hit our goal. So 6 is our final for this path, but then go back and add this original path up. So that's 6 plus 6, which is 12. So the conditions that are laid out for this, like the way my algorithm work is, because I need to actually write this down so we can code this effectively. You can go up, or you can go to the left. Actually, I'll type it out. Who cares? So you can. So the conditions. I hope. Let's do like size 20. So the way this can work is you can go up or left, pick lowest cost path sum. If they equal, pick lowest node cost. If one path reaches goal, automatically take that path. And then finally, once path found, take path sum, or return path sum plus goal node. And that should work. So let's see. So we have the grid, the X and the Y. We can do, okay. So let's just make a queue. Ooh. No, we don't want a queue. We want a minimum, okay, because if they equal, we're not gonna know. We have the idea. I think the idea is gonna work. But how am I gonna code this? Is my question. Because I can do a priority queue, but the problem with the priority queue is that, like, we kind of have, like, if you look here, we kind of have, like, multiple options, right? There isn't just always two. Because, like, here, what could happen is we could either go, like, if I were to run through this algorithm, how many options do we have at one moment in time? We can go up, or we can go this way. So what's going to be stored here, just say 0, is a 1 and a 2. So we obviously take the 1, so this gets popped out. And now we have a 3. You have a 2, and then you have a 3. So what you have is you have 2, 2, 3. So you see that there gonna be multiple kind of options that we can have. And I don't know, I think this would max out at 3. I think the max of this is 3. But like, I don't know. And then you also have to kind of check like the coordinate, the node value. So in this priority queue, I can store a tuple of the path sum, and then the node val, or I could store, I'm definitely going to store the path sum, and then the x and y, because I need to know the x and y so I can kind of travel and traverse through this. So I think I'm going to store this because I need to know the x and y. And yeah, so I say let's try the priority queue solution real quick, and we'll see if we run into any issues. I guess we'll change it up. But I think this should work. And to keep track of like how do I implement a priority? Like, just tell me the import I need for a priority queue. Don't tell me actually how to code it. Alright, thank you. Okay. And then if they're the same, we'll just like append it all to an array or something. I don't know. We'll see. Or I could kind of just calculate, like kind of like a BFS, and just calculate all the possibilities right here, like as an array, and then see. I think that would work, but I don't know. We'll see. I think I should do that. Alright. So PQ is equal to priority queue. Now from here, we're gonna say append a tuple. This tuple is going to have sum and an x and a y. Let's do a node val and an x and a y. Should I do a node val or an x and a y? Because if I do x and y, the only thing that's tripping me up right now is how am I going to calculate, how am I going to know ahead of time if they're the same? Right now, we kind of have this in our queue. We can take that into an array, and we kind of calculate it. I mean, we can kind of just calculate all the paths, so it doesn't really matter, and we just sort it by, yeah, oh wait, I don't think this matters, so let's just store the x and the y. So we're going to store, how is it stored? What is the length? Let's just say width, height, mx, mn, and length. So m is the width, and n is equal to, they're all the same, so I'll just say grid at 0. And these are guaranteed to be what? Okay, they're guaranteed to exist, so we don't have to calculate that. And then we can say append grid at m minus 1, because m minus 1 and n minus 1. And then you can say that's the sum, or the sum right now is going to be 0. And we can just store the x and the y, I guess. So we actually don't have to say this. We can just say m minus 1 and n minus 1. And while pq dot q, we can say for pq dot q, for I in range of length of, what is it, for yeah, I'll just say for I in range of, or let's say L is equal to PQ dot, or just the length of PQ dot Q for I in range of, and let's just call this capital L. I'll just say len. Because the reason why I say this is because once you start popping out of a queue like this, so it's gonna, I'm pretty sure this returns an array. If you try to loop over this and you're popping out of a queue, this range is gonna get messed up. At least that's in my experience in Python. This gets messed up and you get like a bug, so I'm just gonna have this happen. So for now, to see if this is working, I'm just gonna print pq.pop left and return -1. Grid is not defined. I misspelled that. There you go. What is the, how do you add to a priority queue? Oh, dot put. And then this is actually dot get. It's not pop left here. Alright, we have it 0, 2, 2, 0, 1, 2, 0, 1, 2. Okay. So from here, we can move up or we can move down, right? So we'll say sum x, y is equal to pq.get. And let's just try to print this and let's see if it'll automatically like be nice and put it into those values. It does. Okay, so if x is less than 0 or y is less than 0, continue. So this is going to prevent out of bounds because we can only go left. The reason why I say this is because we can only go left. So we can only go negative, and we can only go negative for the y too, because we can only go up or left. So after that happens, this prevents out of bounds, but also still pops it out. We can then pick a value. So we can say pq.put, we'll say sum plus grid at x minus 1, or this is actually going to go y and then x minus 1. So this simulates us moving up, and then x minus 1 and y. So, or moving left. And then pq.put s plus grid at y, y minus 1, x, x, y minus 1. And then move up. And let's just see what happens when we run that. List index out of range. Still out of bounds. Why? 0, 1, 2, 0, 1, 2. plus grid at y. Oops. Oh, because this is an or. I always mess that up. Still wrong. Wait, no, this should be an or. Because if this or that, continue. Let's just do greater or equal to 1. How about that? Will you stop yelling at me? Okay, it did. But nothing happened. I really do need to practice on implementation. Okay, so we have x and y. And we want to check if it's out of bounds. It's out of bounds if x is less than 0. Well, we're going to index it, right? So if x is less than 1 or y is less than 1, we want to continue. The reason why that's the case is because we're going to be trying to move up and we're going to be trying to move. Actually, what I can say is here we can say if x minus 1 is greater than 0, you can do this case. And then if y minus 1 is greater than or equal to 0, you can say this case. Actually, I feel like smarter. Still out of bounds, but why am I getting it out of bounds is my question. Oh, because I'm saying, or no, because I'm saying minus 1 greater than or equal to 0. I'm getting it out of bounds right away is my concern, though. Am I just dumb? Print grid at 0, 0. That should give me 1. If I print grid at 0, 1, that should give me 3. It does, right? Because this is the y and this is the x. 2. Exactly. Okay, so very odd that this is giving me an out of bounds. Because it is, you do index this by y and x. So why is that the case? If x minus 1 is greater than or equal to 0, index it. What am I doing wrong? If anyone sees this, you can feel free to roast me and tell me, but I have no idea why this is getting me out of bounds. Instead of like putting into the queue, I mean, I might have to do that eventually, but let's just print out this. I know that's not gonna do anything, but let's just see. I am getting an index out of bound. 0, 1, 2. 0, 1, 2. Wait, what? Zero, 1, 2. You are not behaving how I thought you would. You're being weird. Okay, 0, 2, 2. If I were to access this grid at 0, 2, 2, am I gonna get an error? I do. 0, 1, 2. 1, 2, 3. 0, 1, 2. 0, 1, 2. 0, 1, 2. This is 0, this is 1, and this is 2. This is 0, this is 1, this is 2. That's the case for all of it. Oh, well, okay, because M and N can be different. Oh, I'm so dumb. Am I dumb? Yeah, I am dumb. I am dumb. Okay. I think I fixed it. Okay, so the reason why this was breaking, it was breaking on this test case because N is the height, basically, and this is the length. So I was putting the length with the Y variable and the height with the X variable. So when I was like doing the decrementing up here, it was messing up, which was causing it out of bounds on this test case specifically. Not this one. This one was fine. That's why I was confused, but it was this one. Okay, well, that was a stupid mistake, but whatever. What are you gonna do? So let's try seeing what happens if we do this. Okay. I wonder what happens if I... So let's say if X is equal to 0 and Y is equal to 0, I'll have like return sum plus, you know, let's just try putting this here. Oh, this is supposed to be n minus 1 and n minus 1. Like, let's just add like the sum. Like, let's just put the starting point. So I don't have to say anything. Let's just return the sum here. So like whatever gets to this point first, we should try and do. Maybe that would work. Oh my, grid. I spelled grid wrong. Grid. If that doesn't work, which I don't, it did work. It's very slow though, which is concerning. It worked for both test cases. Oh, because I was printing probably, but okay. So that worked for those two test cases. Because, by the way, why this is I think is gonna work is because based off these rules, the minimum cost should hit this first. It's kind of like Dijkstra's. Actually, it is kind of like Dijkstra's, but that's not how Dijkstra's works. So I'm gonna take back what I said. I was thinking of a different algorithm when I said that. I was thinking that BFS automatically returns you the smallest path. Just ignore what I said. But the way my algorithm works is that theoretically it should reach the like goal position with the most minimum path, because we take the minimum path up, like the minimum sum path up. And whichever one reaches that one first is obviously our lowest one. But before I actually go and test it out, let's just try a couple test cases. Let's try that. Let's try just this. That is an invalid test case, so that's good to know. Let's try this. That passes too. Is there any other case this could break? Let's try this kind of solution. 1, 5, 4, 5, 4, 3, 4, 3, 2. Like, let's try like something like that. That seems like a pretty like funky test case. 1, 5, 4. What are my other test cases? 4, 3, 2, and then it's 5, 4, 3, and then 4, 3, 2. Alright, if this passes this, I think it's gonna work. Okay, I think this is gonna work. It's really slow. At least it feels really slow, but I think it'll work. It's very slow because we're kind of running through all the solutions. Yeah, okay. I figured. So it's just really slow. It's right, but it's really slow. Okay. So how are we gonna speed this thing up? How would we speed this thing up? Well, if I draw this as a graph, 1 connects to 5, which connects to 5. This connects to 4, which connects to 4. Well, here, actually, let me just go. Okay, so if we had basically the solution 1 connects to 3, which connects to 1. 1 connects to 5, which connects to 1. 1. This connects to 2. And this connects to 4. Okay. So, this is kind of like a... If I were to draw this as like a tree... Can I like scroll over just a tad? If I were to draw this as a tree, let's do like purple. 1 can go to 1, 3. 3 can go to 1. Well, this isn't a tree because this is a graph. This is not a valid binary tree. Because this 3 can point to 1 and it can point to 5, but this 1 down here also kind of points to 5. So let me just draw this as like, there actually is no better way to draw this, I don't think. Well, 1, you can go to 3, or you can go to 1. 3 can go, either go to 1, or it can go to 5. This can either go to 4, or this can go to 5. I don't know if drawing this like this is like kind of like, it's kind of like, and here this last 1 can only point to 1. And then you have this 5, which also shares a connection to this 1. This 1 shares a connection with this 1. So like 3, 1, 1. This is the goal, right? And this is the starting. Bam. And then you have, for this 4, it can go to 2, which this 5 can point to the 2, or it points to that 1, and then this 2 can point to here. So like, this is how like the graph This is like a terrible drawing, but this is kind of like how the graph looks like. I mean, all I did was just redraw this, but like more complicated, I guess. But this thing is so slow is because it's going and it's kind of running through all possible kind of combinations, which that's why it's so slow. So the goal, I would say, is kind of like maybe eliminate, because back to my original idea where it was like, okay, let's have it so, because right now what I'm doing is like I'm calculating like if I had this, say this was my current like path sum, right? These were all the options I could do. What I'm doing is I'm running through each option and going like this, which that wasn't originally what my algorithm was saying, right? Originally my algorithm was saying just take the lowest and run that and add it to the queue and just take the lowest again. That was what my original algorithm was saying. And the reason why I said it like that was because I saw that 200 times 200, if you n square that, like basically what the operation would be if you brute forced it would be this worst case, right? Whatever this number is, which is too big. And I knew that. So why did I implement it like this? Well, the reason why I implemented it like this was because I was concerned about if you had repeats like this, which is kind of stupid. So I'm gonna fix that. So what we're gonna say instead of this, let's just comment, this code down here is good, but I don't want to say that. Let's get our options, which the first one is equal to pq is pq.get, right? So that's our first tuple. And what we want to say is while I want to peek. I don't want to like grab it. Can I? How do I peek with a priority queue? So I just want to peek. I don't want to actually get, because the problem is dot get is gonna remove the item. But I just want to peek. Okay, so I can just index it. So we're gonna say while PQ at 0 at the value I want to grab. So because we're grabbing the sum. Dot append PQ.get. And let's just print out options and return. So, oh my. Okay, that did not work. Dot Q. List index out of range. While PQ and PQ.Q. Oh shit. No, I did not want to say that. Is equal to options 0 at 0. Seems really complicated. This is probably not the cleanest solution, but you know, whatever. So like, let's just say, let me comment that out, testing it. Let's just say we had 2, these values don't matter, 3 or 2, 3, 2, and then we finally had a 3 here, right? Oh. By the way, if anyone's concerned that's watching this back is like, damn, you're going so slow on these questions. Yeah, I am going pretty slow. But I am going pretty slow because I really want to take my time. And when I'm practicing, at least right now, since I'm pretty far out from tryouts, I really want to take my time and practice and really understand why I'm doing what I'm doing, explaining what I'm doing, especially when I'm on stream. I want to explain it because it like solidifies that I understand the problem and why I'm doing what I'm doing and practicing. On competitions and like on when tryouts finally come, obviously I'm not gonna be sitting here drawing every minute detail out and blah blah blah, you know? So if anyone's concerned that's watching this back or watching right now, that's why I'm taking such a long ass time and I'm not too bothered by it. So this works. Now what we want to do is for our options, for O and for C and A, we're gonna basically just do this. So is equal to op or is equal to C. And yeah, hopefully that works. And the runtime doesn't look too much better, to be honest, which is a little concerning. But let's see. Which I would assume the runtime should have got better. Because I'm not, am I effectively saying this? I don't. Okay, it does not look like the runtime got any better. No. Which is concerning. So I'm assuming this test case is kind of like everything is gonna be like equal. So that's not good that this is not working. I thought this would work, but it's not. Maybe I could simplify this. Okay, that didn't work. Why didn't that work? Oh, because if you pop out, yeah, because if you pop out like instantly, the reason why this didn't work is because if you only, because originally you only have one head, and if you pop that out, you're gonna not run this loop because pq.q is not going to exist. So that didn't work, and I don't think this solution is going to work because the amount of runtime that this is going to save is probably, I mean, it's not really that bad because it's only saving, because what that was doing is saving us from going 2O, or what is it, 2N, to just O of N. And I don't think that's, which this is effectively the same thing as this, and I don't think that really matters. So how could I speed this up? I'm gonna try for like 5 more minutes, and if I can't figure out how to speed this up, I mean, could we do no, backtracking wouldn't work because this is too big. If we do a BFS, what about like a BF? Yeah, that's still running through all the values. So like maybe a BFS where you go 1, 4, 5. Okay, so like we take an array. Let's like reset this page. I don't know if this is gonna be any faster, but we'll see. Probably not. If you have 1, 3, 1, 1, 5, 1, 4, 2, 1. If you run a BFS here, the minimum each value can be is this. No matter what you do, this is the minimum value. Now going down here, the minimum value is gonna be 6. And now you have to like calculate this part right here. So here the minimum value, like say like we ignored this, would be, am I cooking? No, I don't think I cooked. Wait, if you run straight across, like say like we turn this into like a subsection, 5 and then 6, and then this goes to 2, and then you're left with 1. This would be 7. You just take the max or whatever. But I don't think I cooked actually. I think that's just a coincidence. But this is true. And what you can say is you can take this current node. So you can kind of like go through the same pattern here. Take this current node. This is equal to the min of one of these. So this would be 7. Take this current node. This would be the min of whatever this is. So this is 6. Go to this current node. This would be the min of whatever these two are. Add it up, which is 8. And then you go here, and then the min of whatever these two are is 7. So like you can kind of like, I mean, I guess that's a BFS or a BFS, but like, is this faster though? Is my question. And I don't think it is. Because this, I mean, well, actually, this is O of n. Technically. Because the problem with my algorithm, what it was doing is, if, like, say we had, like, 1, 3, 1, 1, 5, 1, 4, 2, 1. If you went here, say you recalculated this number. You go here, you recalculate this number. Well, here you still calculate this again, and here you calculate this again. There's a chance that you can do stuff twice. So it's like almost n squared. Actually, I don't know if it's n squared. I don't know what the correct thing is, but there's multiple calculations happening here. And the way to fix that is either store it in like a visited list or do something like this where you have like the minimum. So like if the new value you're trying to insert is bigger than what it is, then don't insert it. You know? But is that smart? Well, how would I do that? That is smart. That's actually probably the solution because, okay. the runtime of this algorithm I just thought up of is m plus n. Where mine, I don't know what it is. It's mn, probably. It's probably like m times n. Because if you think about it, you're only going through each value one time, and then you're done. So the runtime of this algorithm is m plus m, which is way better than m times n. So what we can let's try this, because obviously this solution is not working, and trying to optimize it's not going to work. And it's not kind of what I thought of originally. But let's try this. So we're going to have the original values. Well, actually, before I cook this up, let's test it with this. So you can calculate, this gets turned into 1, 3. Actually, let me write this in red. 1, 3, 6. This is 5. So this calculated is this itself. It's the node plus the min of x minus 1 and y plus 1. So this would be 6, 7, 8. And then the value of this would be same situation, which would be 6 plus 6, which is 12. Okay, I think this works. I think the solution works, so we're gonna try it. Now, like, how would I loop over this? Well, I could just have one for loop for each row. So I could just do it by row, right? So I could just take the row, and if y minus 1 is out of bounds, we'll just add 0. So like we could just like kind of think of it like this. 0, 0. These zeros are here to prevent it from going out of bounds. Look up 1, because add it, and then eventually just return what the new goal position is. I think this is gonna work. So we're gonna delete all of you. Besides this part's so nice. And we're gonna want to return, because we're gonna modify the grid value. n minus 1, n minus 1. And just for some note, grid is y, x. So for y in range of m, so for each y, let's see, this is, wait, I don't know if I calculated this right. Whatever, let's just send it. If this doesn't work, I'll look at a solution. Print xy. So what I just realized is this isn't n plus n, this is n times n. 1, 0, 1, 0, well, yeah, this is m times n. Okay, yeah, because you have y amount of rows times, basically times how many columns there exist. Alright, whatever. I still think this is better than the last solution though, so I'll try it. If this doesn't work, unfortunate. So when you're calculating, you want to take the min of these two. So left is equal to, first we gotta like check this. So we're gonna say if, or left, how do I want to say this? Like, is there a nice way to say this instead of just like doing multiple statements? I'm kind of stubborn when it comes to that. This is gonna be s is equal to the min of new is going to equal to the min of if x minus 1 is less than 0, or is, you're gonna say grid at y and at x minus 1, else you're gonna say 0, and then you're gonna say grid at y minus 1 x if no, I code in C++ when I'm doing like if I'm just doing LeetCode, I'll just do Python. But when I'm doing like CSCS or USACO or Code Forces, I code in C++. But like normally when I'm doing LeetCode, I'm just kind of like practicing, I'm not really focused on, like, I don't always want to be coding a C++ because Python and C++ are both useful for CP, especially. So I use LeetCode to kind of practice my Python, and then I use CSCS and all that to practice my C++. At least that's how I do it. Alright. That was wrong. Yeah, I am. Oops. I'm trying to cut, like, I'm in my freshman year, so I'm trying to try out for my sophomore year because it happens in September. Okay, what happened here? Oh, well, I'm saying the min, right? So I want to say 1E99. This is terrible code, but whatever. Okay, that worked. See, the runtime. Oh, it actually passed the last test case, and I was printing. Oh, wait. Oh, God. Oh, shit. It actually worked. And I was still printing, and it ran faster. All right. Let's see. There we go, baby. All right. I knew the solution. Let's go. Okay, so what did we learn for that problem? Make sure you double check your algorithm and make sure that it's not accidentally running everything, doing extra calculations, especially when you need time. Wait, I wonder what my other algorithm, what was that runtime? By the way, anyone watching, if you want to see what the solution I was trying earlier, it's like the same idea, but this is the code. So like, if you look at it, you would be like calculating that, like, there's a chance of it, like if you had like 1, 2, 3, 4, 5, 6, 7, 8, 9 in these like middle regions, anything that isn't the start, kind of, you have a chance of double calculating because the way that it works is up, left. So here you can go left, up. This you can go left, up. So it's like you can kind of double calculate this whole kind of region right here. But with this solution, you just run through it one time, which is m times n. So that's why I was getting a timeout here. And maybe I'll sit down soon and actually do it with summations and actually figure out the exact runtime, but I don't know. You've been doing pretty great. Competitive club at my uni. Yeah, my school is really, really good for competitive programming, like really, really good. And I have a friend who's in it, and he's been trying to convince me to like join the competitive programming team. And I wasn't really sure about doing it because I really suck at competitive programming. At least because I started, like, if you look at my LeetCode streak 46 days ago, that's when I kind of started grinding. But like the first month, I was only doing LeetCode. I didn't start CS. I only started CSCS like couple weeks ago. And like the USACO guide and everything, only a couple weeks ago. But he's been trying to convince me to join for a while, and I was like, I wasn't really sure, but then now I'm 100%, and I'm a little nervous. This is a big ask to clutch up in 6 years, or 6 months, but hopefully I can do it. I've been putting a lot of time into it recently, and I've been having a really good time. But I will say, I do miss coding projects because I've been putting a bunch of time into competitive programming. Yeah, and you know what's scary is, like, the thing though is like what you're like for at least me, the reason what stresses me out so much is like it's like developing problem solving skills. Like I've been programming for around like 3 years. Like so it's about to be 4 years soon, right? I was programming before I got into college. And like so like I'm kind of like used, like I'm able to like learn new technologies and like stuff like that pretty like, I wouldn't say easily, but like I know what I'm doing, like I'm comfortable. But this is kind of like new. It's like, to me, like it's more problem solving focused. It's different. Like this is just different. So it's like I forgot what it was like to be like just like bad, like bad, you know. So like it's just like I've been getting humbled bad. Like every time I go to the team, like the training room with them, I get pretty humbled. But yeah, so I haven't been humbled like this in a while, but it's honestly pretty good for me. How competitive is it? Do you know the ratings? I don't know the ratings of people that qualify, but I will say our top teams have people in red. Like on Codefosis, they're great, like Grandmaster, and they've gone red. So that's the top team though, and I'm not trying to get into the top team. I'm just trying to get on the team, and I would say probably like their rating. Maybe like 1,000 or 800 range, I think. I don't know exact. I just know if you have solid fundamentals and you can like balance yourself around Div 2, Div 3 level, probably more around Div 2, you should be able to get in. Like I think that's how competitive it is to get in. Yeah, I feel that. Because like, especially for me, since like I have to like kind of clutch to get in. Once I get into the team, I can kind of cruise until it comes to like time to try out for varsity and everything. I can kind of like cruise. But dang, dude, this takes up a lot of time. I'm not gonna lie. But like, I have fun doing it. I'm not gonna lie. And also, I do, like, so a lot of people say like, oh, if you do competitive programming, it doesn't really translate like to like real programming. But like honestly, dude, when I go to my projects, like it does, like doing competitive programming does make you a better programmer and a better problem solver and everything. Like it is worth it. Because if you look on YouTube, a lot of people are like, oh, leak code, like doing not necessarily competitive programming, but they're like, well, leak code style questions, like it's not helpful because it doesn't teach you how to like build projects, which is true in a sense, right? But that's not, a lot of people make it out to be like, oh, leak code's just a complete waste of time and it's a fault of our system, of like the job market system. But like, especially if you start doing competitive programming, I've definitely noticed some like translation. There is translation, and it does make me a better programmer. Because like when I'm developing stuff, like I think more about like the you know how you have to think of test cases. I always think of like ways this thing can fail. I system proof it. I also like, especially if I'm doing like stuff that involves data structure and algorithms and more of that kind of stuff, I definitely am able to do it more easily and stuff. It does translate. It does translate. So I have a good time doing this. To me, the way I like to compare like competitive programming is it's like TikTok for like programming, you know? Like, because when you build projects, it kind of takes like, if it's a big project, it's like it could be like months until you can like finish it and receive dopamine. But like with these problems, like dude, max 30 minutes. Like if you're like not trying to be too serious, max 30 minutes, and like if you solve it, you're like, you get a hit. It's kind of fun. I'm not gonna lie. This is CP is TikTok for programmers. But like competition, no, I wouldn't say like in contests, I wouldn't say that. But like if you're practicing, just trying to have some fun, I would say. Because like, you know, sometimes in between classes, I'll be like, damn, I can't really work on my project right now. Because when I work on my projects, I kind of have to sit down and really like focus. So I'll just like knock out a leak code question or something, or like do a quick question. That does just for some fun and some practice, you know. That's the way I like to think of it. All right. So how many leak code problems did we do? We did this graph problem. We did the daily. What else did we do? What did I do today? Oh, we did combinations, we did backtracking, we did a graph, and then we did the daily. So I would say let's go to CSCS. Because we still have an hour and a half left in the stream. Of on-stream practicing. So let's go to CSCS and let's do some practicing. Okay, so just some updates for anyone that was at the original stream. I finished chessboard and queens. That problem a couple days ago. What was wrong with my solution was, well, first of all, I coded it wrong, which I'll go through this and walk anyone. Oh, I didn't submit it. Oops. So I can't go find the old code. But basically what I was doing is like, I'll just look at this solution. Actually, I'll just pull it up in VS Code. Okay. Okay, for this one, what originally I was doing is let me delete these comments. That wasn't important. So originally what I was doing is I would take the input here, and what I was trying to do originally, which I wish I had the code, you can look back in the live and see, it was the first stream we ever did, but I was trying to like compare the char values. Like you see how like here, oh, by the way, I'm sorry if anyone wanted to do this question, I just exposed the solution. You should probably like turn off the stream, but basically I was like comparing the char value and everything, but like that's kind of stupid because you could just turn this into like a bitmap where like anything you can like place on would be ones and this would be zeros. So that's kind of what I did. It was like easier on the like programming side because I can just say, especially in this like DFS part, or it's not a DFS, you know what I mean, it's a backtracking, but we can say, instead of just being like, oh, if it's this, if it's an attack, if it's a blocked, blah blah blah, you can just say if this is not the case, right? Because one means you can travel on it, you can place a queen there, and yeah, so you just say that, and that just simplifies it so much more. Also, this was an error, because I had this whole code written up, and it was like bugging out, and it was giving me a really big number. The reason why it was giving me a really big number was because of this line right here, line 11. So, let me explain what I had originally. So, originally, basically, the way this problem works, like, imagine this is 8. If you get to the end, right, if you're able to place the queen at the end, the last queen, the 8th queen, here, it's valid, right? That whole, whatever you backtracked is valid. But what I was doing was I was checking if we placed it here, like, if you get to the last point, like, you actually place this 8th one, can we place in the other 8 spots? So it was, like, multiplying my answer by, like, 8. Whatever, you know what I mean, instead of saying if we can place in the last spot, right? So I was saying if y is equal to size, then add up, which the problem is like if you get to this endpoint, you're gonna get 8, you're gonna get 8 counts, right? So that's why I had to say size minus 1, and then also this didn't used to exist and everything, blah blah blah. It was a whole thing. But yeah, so that's just an update for anyone that watched the first stream and was like, damn, did he ever solve Keen's chessboard and queens? And I did. I did not solve grid paths. Grid paths is too much pruning, and I'm gonna wait. Digital queries I have not solved yet, and I don't. We could actually try to tackle this problem today in the remaining time we have, but I don't know if I want to, because I really want to start practicing sorting and searching. And yeah, I was working on these 2 problems. I really thought this was gonna work, but I hate interval problems, and this is kind of like an interval problem. So I was like, okay. And then Ferris wheel, I don't know how that broke. Actually, I think I do know how it broke, but I kind of forgot the code I wrote into it, so I'll kind of go back. So I'm gonna pick a problem here in a second. I think you got the right mindset for it right now. It's definitely a matter of how many hours you invest into it. If you keep doing this for some time, you'll definitely see some improvement quite a bit quickly. Yeah. I don't know. I do have a good time learning all this stuff, so, you know, it does get a little upsetting sometimes, but I feel like I've been humbled enough times to where I'm used to it. Yeah, because I thought grid paths wasn't going to be that bad. Like, originally when I looked at this question, I was like, oh, this is kind of stupid. And then I realized that if you don't prune anything besides, like, going out of bounds, you're like, you're not. There's like 7 prunes, I'm pretty sure, or something around there. Because I told my friend, like, I was trying to do that problem. He's like, don't do it, don't do it, don't do it. Just wait till later. I was like, okay. 2 sets. What problem do I want to try? I don't want to do this. By the way, I can. This is just contains, and I don't feel like doing this. I've done this problem so many times before. We're gonna actually do a real problem. Missing coins. What is missing coin sum? Yeah, the end amount of integers is the smallest sum you can create. Oops. 29127. 4, 5. It's the smallest sum you cannot create using these coins. Okay. This is kind of like almost like a follow-up of 2 sets. I feel like it's like a harder version of 2 sets. I don't know. I think I'm gonna try 2 sets. Let's try 2 sets today. I think that's a good problem to practice. Let's get this problem done. If we can get this problem done in a good amount of time, we're gonna do the missing coin or whatever it's called. So, what comes to my mind? Are these contiguous? No, it's not, so that makes it harder. But we can prevail. Okay. So given my intuition that comes here. By the way, so this is 1, 2, 3, 4, 5, 6, 7. My initial intuition is prefix summit. Now, why would that work? So if you have 0, 1, a 3, a 6, 10, a 15, 21, 28. This is your prefix sum, right? Oh, I don't know why I wrote that. But the problem is, what would make this really easy is if it was contiguous. But since it's not, this is a little harder. Alright, good luck. Thanks for joining the stream, by the way. Hope to see you around. So, this initial prefix sum is not going to work because they're not contiguous. It's not like you can be like, okay, if I take the minus of this and if I take this sum of this array and this sum of this array, do they equal, and just like 2 pointer? That's not going to work because they're not contiguous. So, what you can say though is what I'm thinking is, how big can these numbers be? 10 to the 6? Alright, you are not going to be able to... That's not even close to a backtrack. Okay, you can, I'm pretty sure 10 of 6 you can square it though. And that still counts under 1 second. How much time do I have? 1 second. I think you can square this and it'll get away with it. Because what I'm thinking is, obviously this has to be 2, right? Well, first, you know that only 2 things can, like, you can only split something up into 2 like parts if the target sum is even. Like, it has to be even, right? Because you can't split up an odd number evenly, you know? So we can technically split this up. We can split this up, and we can split that up. So these are the three sums that we can kind of look at here, right? These are like the three sums you can like look at. So let's look at this one. This is gonna be 14. So the target is 14. My question is, do you have to use all the elements up? I'm going to assume that you have the 1, 2, 4, 7. 1, 2, 4, 7, 3, 5, 6. Okay, so I'm gonna assume you have to use all the elements up. So instead of saying this part right here, like where you can have 3 targets, you're only gonna check this. So the first thing our program's gonna do is check this. If this is odd, then print no, because the sum of 6 is 21. If you see that, that's odd, so that's not even gonna work. It even says it right here, which is kind of a useful hint. So we're only looking at this final value, right? So if you're looking at this final value, you can kind of, I'm pretty sure we can n square this and get away. So I'm gonna try it, because my solution is, let's take this like, actually, oh wait, what the heck? Prefix sum doesn't really even matter. Well, it does matter at the end to calculate if you can print into the target, but like, is there a pattern I can take away from this? Let me actually try to see if there's a pattern. If you have 1, 2, 3, 4, 5, 6, 7, the target is 14, right? We already said this earlier. So let's do like kind of like a 2-pointer approach. So we'll have this subarray and then we'll have this array. Right? So let's add the first one here. So the sum here, let's take this one. See, that doesn't work. That's not a pattern. Yeah, it's not a pattern at all. Two sets. Yeah, 10 is 6. I'm gonna try this for, I would say 15 minutes, and we'll see what happens. How do I want to split this up? So I was thinking originally, well, let's try my idea actually. You take the first two, you add them here. Now since this is less than that, you're gonna add a 3 here. Since this is less than that, add a 4. this is now a target of 4. This is a target of 6. Since this is less than, add the 5. This is 9. Add the 6. This is now 12. Yeah, that did not work. So that, my original thinking was, okay, well, we can take like this pattern and add together, but like that pattern's kind of disproved right here. But one thing that is true, I think, is that these last elements kind of have to be in each kind of array, right? So like 7 goes here and 6 goes here. I think this might always be true. We'll see. We're gonna test it with other things, of course, but we're gonna try that. Now, since 6 is less than 7, we can add the 5. Now, since 7 is less than that, we can add the 4. So the sum of this is 8, 9, 10. I think it's 11, right? Yeah, this is 11. The sum of this is 11 too. So since they both equal, what can you do? So since they both equal, you can maybe get away with well, here you can add the 3, gets you 14. Here you can add the 2, which gives you 13, and then you can add the 1. So yeah, they're not the same, but that does work. So let's go back up to our prefix sum. What's a no? We can try 4. Let's try 4. So 1, 2, 3, 4. Our goal is to split it up into targets of 5. So in our subarray, we can have 4 and a 3. 4, 3. This is kind of like the prefix sum of it. Well, since this is less than that, we can add the 2. Now we're at 5. Since this is less than that, we can add the 1, which gives you 5. So this is the subsets. All right, that worked. Let's try 3. Add the 3, add the 2. This has to go back. That works. All right, so let's try it for. Okay, so this kind of like pattern I just found is kind of popping off. I'm not even gonna lie. Let's add an 8 to this. Oh, I can't do math, bro. $34? I don't think that's 34. It's 36. Yeah, that's 36. Okay, me when I can't do fucking math. Okay, this is also summation, but I don't think that matters. Alright, 36 is a valid number. So your target's gonna be 18. So let's try this pattern with this array. If this works, I'm gonna code it, and we're gonna see what happens. So, subarray 1, subarray 2, you start with 8, 7, add the 6, add the 5. What are we currently at? Here we're at 13. 6 plus 7 is what? 13. Since they both equal, just add the 4 over here. This is now 17. Since 6, we can add the 3. This gives you 16. We can add the 2. That gives you 18. And then you can add the 1. So these are 2 valid subsets. Alright, let's code this. Let's see what happens. I think this works. What is this problem called? Subsets. Right? So yeah, I think this pattern works where you take the back and you kind of work backwards from the solution. You take the big, kind of be greedy with it. You take the biggest and you work your way backwards. So if you do the smallest, you kind of have infinitely many opportunities. But you take the biggest, it allows you to narrow it down more in this like greedy way. So, give me this. I mean, I could probably get away with doing that. This is an O of N operation, so I could probably get away with doing this in Python. I could do this in Python. Let's do it in Python real quick, and let's see if we can get away with doing it in Python. Oh wait, what the heck? I already tried this problem. Oh, what is this? That looks terrible. Whatever I try, get away. Alright, so we need to say pi 2 sets pi a for in.txt. And then in our inputs, oh, you can just input a number. So let's just do 6 for now. And yeah, so n is equal to inputs. If n, okay, so the sum of all this is calculation. This is a summation, by the way, this is a summation. This pattern right here, because you get a range, you get this like range, and this, and the sum of all this is basically 1 to n. So it's, this would be the answer to that. So to get this whole sum of this, it would be this summation. Usefulness of summations. If you're taking computer science class, pay attention to summations, and your calculus class. Very useful. Return n times n plus 1 divided by 2. So we can say if calc of n divided by 2, or if calc of n, here, what we'll say is sum is equal to calc of n if sum 2 is not equal to 0, print, or let's make this a solve, and type all that in, return a no, print else, we're going to say target is equal to sum divided by 2. So yes. Now we can have a left and a right. Kind of just happening. And okay, well, I kind of want to like, that's not good. Why is my YouTube messing up? We'll just set this all to -1 times sure. The reason why I'm doing this is because I don't want to have to push and pop. Because I want to kind of push the front. I want the, it's kind of like, I guess, a Q. No, it's a, wait, what am I thinking of? I like brain farting right now. I want the bottom elements to go in last. It's a stack. It's a stack. It's a stack. I want it to be like a stack, but like, you know what I mean. It's fine. Actually, I'm overcomplicating it. I'm overthinking it right now. Whatever, just leave it like this. We'll figure out about reversing it later. I don't think it should matter, but, you know, whatever. So, we have our left and our right, which I can just say, I can just simplify some lines by saying this. And now we can start working backwards. So, left sum 0, left sum, actually I'll put it left sum, right sum is equal to 0. They can all just both equal each other at this point, I guess. Okay, so left dot append the biggest value, right dot append the biggest value minus 1. Ooh, wait, can I just like kind of like simplify this? Why am I thinking about like simplifying so much? I should probably calm down. Well, actually, this is going to be equal to left sum, which is going to be n, and then right sum, which is n minus 1. And then left dot append n. Ooh, wait, you know what I could do? Actually, that's really stupid. I shouldn't do that. That's really dumb. Let's just leave it like this. Left dot append n, right dot append n minus 1. Alright, does this code work so far? Yes, it does. And then n minus equals 2. This is kind of what happens when we run a tick. So we're going to say while n is greater than 0, here's what we're going to do. If the left sum is less than the right sum, say this. If the left sum is less than the right sum, append to the left sum whatever n is. Else if the right sum is greater than the left sum, right dot append n. Else if they equal each other, left dot append n, right dot append n minus 1, n minus equals 2. And then print left and right. Why'd you get mad at me? Oh, right here. And then what we want to say, oh, before I even run this, right sum plus equals n, right sum plus equals n, left sum plus equals n, right sum plus equals n. Nice one. One, 5, 3, 1, 6, 4, 2, 0. If I tried this with 8, 8, 6, 4, 2, this is kind of what we wanted. Where did I write this all out? What the heck? There we go. Where did I write out this code? One. Okay, that's not what I expected, but let's see what happens. 8 plus 6 plus 4 plus 2 is 20. 7 plus 5 plus 3 plus 1 is 16. Okay, so this is wrong because what I want to say is this and left sum is less than target. T, and right sum is less than target. Because what's happening is basically it's just running this loop, but like in our condition in the code that I wrote out, I want it to not do that if they like equal the target. You know? I don't know if that made any sense. This is also wrong. This is also wrong too, this if statement. There we go. There we go. So 8 plus 5 plus 4 is 17. 7 plus 6 plus 3 plus 2 is 18. And then we can run one while loop while n is greater than 0. We can say left sum dot append n minus equals 1. And then we can say go down here while n is greater than 0 and right sum. So this kind of like just adjusts everything. And then here you go. And then also append right here. Go. Oh, this is supposed to be n. So 85417632, is that valid? The right is valid, we know that for sure. Is the left valid though? $18. They both look valid. Let's print out the left, let's print out the left sum and the right sum. 18, let's try 7. Let's try 6. Let's try 5. Let's try 4. Let's try 3. 2. Alright, that looks like it's working. Let's fix this up so it actually like prints out correctly. And we want to print, how do we want to print? Okay, so let's print how am I gonna, actually now I think about it, I guess just say return print no and then return. And then go down here, print length of left, then L reversed, or print that, then print, or not length of L, but L reverse, then print R, then print R reversed. And then print yes. Alright, I think this is valid. So let's try and submit it. Okay, you are going to cuck me. Alright, 2sets.py. I do have a feeling that this is going to be TLE. Let's see. Okay. Wrong answers. And I have a feeling I'm going to do a little cheaty cheat. Which I don't know if you guys are going to support this, but I'm going to do a little cheaty cheat to make sure that it's not only passing when it's saying no. Oh, okay. Obviously. Okay, see, this is why it's important, okay, to cheat every once in a while, okay, guys? This is why it's important to cheat every once in a while, okay? Because you see, that was really dumb on why it was not working. That if we didn't look at the solution. So cheating every once in a while is good if you have a suspicion that it's not behaving how you wanted it to. For the range, start at here, go to here, print I with a space. I'm pretty sure they want a space too, and then you know what'd be crazy? Let's go a little crazier. Let's make this even more efficient. Yeah, I like making things more efficient. Nice. 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 There we go. Now we don't have to say this anymore. Because the length is a null event operation. I think, at least, right? Yeah. Because Python doesn't store automatic like dot length, like how other languages do that. So the reason why I did that is because we don't want to have multiple O event operations running. It doesn't really matter, but whatever. Alright, let's print our size, and I think this should work. Print statements, you're annoying me. Stop. There you go. Behave. Oh, no. Alright. It's still working and everything, right? 3 plus 4 plus 7? Okay. Now let's submit it again. There we go, baby. Just like that. Okay, this one came really close. I should probably rewrite this in C++, but I just want to get this problem done. Because, fun fact, I did try this problem before. And I think I was so lost and sad that I had no idea what I was doing, but we came back. I don't know when I tried this problem, actually. We came back and we kind of instantly thought of the solution, you know, find the pattern. What did we learn from this problem? Prefix sums actually kind of didn't do anything here. We learned to analyze patterns, and also greedy is really important, because what I was doing, this is why I love working from and especially problems where it's like find from the start how long does it take to get to a goal, always work from the goal. But like, if you see, like, you have to start from the biggest, because if you take away the biggest, right, it limits your possibilities even more. It's like, it's easier to take away from the biggest than taking away from the smallest, because there's more window of stuff to like do. But if you take away from the biggest, it kind of closes that window. You can't really do anything if you go by the biggest, you know? It's really important to understand, especially if you're doing problem solving, if you're doing CP. It's a very common theme that comes up, I see. Should I waste my time and recode this in C++ or no? I'm not going to. Alright. Number spiral I hate. 2 knights. I did look at this problem. I'm not gonna lie. Well, you guys know I'm not lying because you can see the purple from when I clicked on it. But I don't know if I want to solve that problem right now. Because we've done a lot of graph and like backtracking problems today already. And I don't want to do anymore. Digit queries. Do I want to give this a shot? Do I want to give digit queries a shot? Again. I mean, it is about finding patterns, so... Let's give digit queries a shot. How did I learn programming? I learned it through this guy named Brocode. And I learned off his Java series. Because I really liked the way he taught. When you learn how to code, you have to learn from someone you like how they teach. Because if you don't like how they teach, you're not going to understand it and you're not going to learn it. That's my advice when it comes to finding how to learn. And the best way to actually learn, though, programming isn't like, I would say, reading. You can't just read something and be like, okay, I know what I'm doing. You have to really build stuff with it. So when you work through a course or you learn stuff and you're trying to learn programming, yeah, I really like Brocode. When you learn how to do stuff, I would say you have to build. If you don't build anything with programming, you're not going to learn. You're not going to learn how to do everything. And then it just takes time. Make sure you're always progressively just trying new things, even if it scares you a little bit or you find it hard. If you're not finding something hard and whatever you're not working on is like not at least a little challenging, you're not learning. So just build projects. And yeah, don't be afraid to use Google too. Because don't be like, oh, if I Google, I don't know what I'm talking about. Programming is not something you can just memorize and be like, okay, if I use Google, I'm stupid. No, that's not how that works. But yeah, that's the best way I would say to learn programming. And the way I learned, like more specifically, is I tried to program a while ago, but for my first advice, I learned from someone who was like really lame, and he was really boring. And also I tried to learn C++ too, that's my first programming language. And I never really took the time to understand each topic, so I didn't know what I was doing and why. I wasn't building anything with it. I wasn't building projects with the topics I was learning. I was just kind of going through the course and like, okay, I know this now, and just following along. But like that wasn't useful because I wasn't practicing, I wasn't building. So like when it came time to actually try to build stuff, I was just failing over and over again, and then I quit. Then I came back like a year later. I watched Brocode, and then I took a different approach to it. I liked the way he teach. It made me excited to learn and keep coming back and learning and to learn more. And every time I learned a topic, like an if statement, a for loop or something, I would build a program that involved it. I would actually like get my hands dirty and build with those tools. And it just made me learn so much faster. And then from there, I actually was like, okay, I kind of think I know what I'm doing. And then I just started building stuff. I did game dev for like a little bit, like from scratch game dev for like a while. And then I hopped around to a bunch of other different stuff. That's how I learned. Everyone has their own path. Alright. Query stream. Alright, digital queries. So you have an infinite long string that contains all positive integers in increasing order. Your task is to process Q queries from their form. That's fair. That is fair. C++ can be really annoying though because of all the libraries, like all the features it has with it. It can be really confusing, especially if you don't like know, because it can have so many different types of stuff just out of the box. It's very confusing to read unless you know what's happening and what some specific function does. I can sit there. Let me lock in. I'm gonna lock in and finish this and try to get this problem done in the next 30 minutes, I'd say. Alright, so you have an infinite long string 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and you have a query, which is basically the digit it has. So you have, let me just type this out actually. 1, 2, 3, 4, 5, 6. 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. Oop. Okay, that's fine. So you're given this. Basically, there's a pattern in here that we're gonna have to find. If I stretch this out, oop, that got distorted. It's over. Thank you, thank you. Good luck to you in anything you're pursuing. So if you have a string, the first 0 to 9 is fine, or I guess 1 to 9 per se. This is normal. These queries are normal. But once you pass this threshold, which is the 9th digit, you get like weird. We'll say up to here. So say if I wanted the digit 10. Well, digit 10, this is a 1 base index string by the way, would return to me digit 10 would return to me 1. 11 will return to me 0. 12 will return to me 1. 13 would return to me 1. 14 would return to me 1. 15 would return to me 2. Okay. So we look at this. We see a pattern that's coming. Well, what I do see is that the even queries are like the digit of whatever number sequence you're in, so like 10 to 19. All evens would be 1, no matter what, right? But the odds cycle. So every odd digit is kind of like an index. I mean, this difference is -1. This difference is -2. This difference is -3. While the odds are always just 1. So if I were to take the number 12, since this is even, we know that this is going to return 1. Now if I were to take the number 19, we know that this is not even. So this would return 7 because 9... Actually, what would this return? What is the pattern to get out of this? It's not -2. Since this is 9, this is the 9th. If we look here, this returns 4. So this would return 4, right? So I kind of see this pattern forming, but what can I do with it? I can see that we have a -1, -2, -3. But what am I going to do with that? That doesn't really help me. Because the thing is, like, this also logic would only work for 110, like 10 through 99 base like numbers. Like at least in the string, this range. But then if you were to have 100 to 99, you're at a different kind of like range, right? Because here, well, I don't even know what this, well, if I start at 100, 101, 102, 103, well, I don't even know what number would query this, right? Because you can't just say like, oh, what if I query 1? Well, that doesn't work because we're not in this range. I would have to like manually calculate all the way up. Okay, so if the first range, let's just use this example. If this first range, we can query it through, oops. If this first range, we can query this through 1 and 9, right? In this second range, we can query this through 10 to 30, right? Because if this point right here is 19, this 20 would give me 1, 21 would give me 5, 22 would give me that, 23, 24, 25, 27, 29, So this would be 1 through 29. Not 30. This would be 10 through 29. And then this pattern would be 30 through 49. Why does that help me? Why would this help me? That's my question. There is a pattern to this and some formula, because this is going to get 10 to the 18th, and that's not possible to calculate in a second. So there is some sort of pattern I have to find. 30 to 49. So this range from the 2-digit range, so like X and Y, I guess, or actually a better would be digit 1 and digit 2. A valid like set is 2 times 10, and I'll get to why I'm saying this in a second. It's like 20. It's like 20 you can go through before you get to the next one, right? Well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Ten, 11, 12, 13, 14. And like on the, now if I were to do this one, what is like a valid range on this one? Well, it's still this, which is 20 times something. So this would be 3 times 10, or 10, right? Because you have to wait for 3 digits to shift 10 times. So a valid range of this would be 300, right? So this changes 9 times, and this has to change 9 times, this has to change. Like a valid range of 100 to 200 has 300 changes in it, right? Because one set of numbers has 9 valid changes in it. Or 1 through 10 is 10 changes. Now if you had this for this too, well that's 2 times 10, because then there's this many operations. And then if you have a third one, if you go to the third digit, then you have 3 to the 10th. Now if I were to go like to like maybe like digit 1, digit 2, digit 3, digit 4, now you're getting to like, okay. Yo, oh wait, whoa, bro. Today was, I did get happy number. And I did the minimum sum array or whatever, and like basically first try. Like I came up with the solution instantly. For that minimum sub thing or whatever. And also, if you go back in the stream, I did minimum path sum. I did, wait, let me actually click on the problem. I did minimum path sub. Oh, if you don't look at the code if you want to like solve it on your own. I came up with like the solution, but then it was like too slow, so then I rethought my solution, and then I came up with this solution. Because the problem was I got TLE, so I had to do this, which this is O of M plus N, which is pretty sick. And this worked like instantly, which is pretty cool. And I'm adopting like your terrible coding style too. If that makes you feel any better, I got the 1E99 when I'm taking the min of everything, a bunch of ternary operators, and I also I also did combinations, which this was like a warm up. So like I don't really count this, but this was like a warm up backtracking problem that was really easy. Oh yeah, n times m. Sorry, yeah, that's what I meant to say. It's m times m. But then I did this like backtracking to warm up, which was really easy. This ran first try, which I'm pretty impressed with. Actually, it didn't. I lied. When I implemented the solution, it ran first try, but I was like printing and shit to make sure it was working. I did backtracking. Is that stupid? No, I did not DP. I did not DP it. Oh, minimum path sum? Let me show you. Oh, path sum? Oh yeah, I basically kind of DP'd it. I guess, if you think about it. N can be 200. Or like, wait, the way my thing worked, I'll just draw it out. Like, say you have this path, right? Actually, let me do this, right? So you have this path. Well, what I do is like, you can either move right or left, right? So like, from this, and then like, I kind of added like zeros on the edges, like on the out of bounds. Right? So like, basically like the way this would work is like, well, what's the minimum of between this and this? Well, that's 1. What's the minimum between this and this? Well, since it's 0, you just do 1. So that's 3 plus 1, which is 4. Then now this is 4, right? So what's the minimum between this and this, which is 4? This is 5. Now you go and calculate this. What's the minimum between up here and here? That's 1, so this is 2. The minimum between 4 and 2 is 2, so this is 7. The minimum between 7 and 5 is 5, so you do 6. Because you take this plus the minimum between these two. Yeah, isn't that crazy? That I came up with that? Cause like, oh wait, I'll show you my original code. I tried basically like, because my original idea was like, okay, let's basically like solve it like a graph problem. But the problem was is like, I realized like halfway through that I was doing like extra calculations between this range. Like I would calculate these numbers like multiple times. But like basically I try to priority queue it based off like what the current minimum path was. Like I was trying to like basically almost do a Dijkstra's. Like with this one, and then it was too slow, so I was like, okay, I rethought it, and I was like, and then I realized that this works, so I was like, oh, let's try that. But that's how I saw that one. Interesting. I don't know if that's a good interesting or a bad interesting. What, for this one? Like, if I didn't have TLE, it doesn't work, no matter what. Yeah, I did. It was like, I'm not saying it was with Dijkstra's, it was like, it's kind of similar. Well, like, because like you would backtrack to see like if it would change. Like this would work if I didn't have TLE, because I tried it with, it passed like a lot of them, but this one is just too much, you know. But yeah, I'm pretty sure this would work, but whatever. That's not. And then I went. Hey, you know what's crazy? You know what's crazy? Because I didn't tell you this, but 2 sets I was scared to death. Okay, don't mind this. Okay, I'll explain this in a second. But 2 sets I was scared of, because I tried this like a couple weeks ago, or like a week ago or something. I was scared of this problem. But I was scared of this problem, right? because my dumb ass was like, okay, let's start from the minimum value, right? And then try to work your way up. But then I realized the way I did it was I started at the max, basically. Like, I'll show you the code in a second, but I don't want to erase my digital queries code or through your thought process. But like, basically, you have a left subarray and a right one. You start right here, you like add 7 to it, and you add 6 here right off the start. Like, say you had n is equal to 7. 1, 2, 3, these are your options, right? Blah, blah, blah. Take the max, whatever has the minimum value at this point, add the next number. So this would be 5. So this is 11, so then add 4, and then blah, 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 until you get to the target. If you hit the target, then append all the rest of the values here. You know what I'm saying? Or append, like, whichever one hits the target first, append the rest of the values to that subarray. And then just print it out. And the reason why this one didn't work is because I accidentally was using Python's print statement. So it, like, was printing weird. But this one worked. Don't mind this code, okay? It's just, whoa, chill. Okay, it's just manual pointer magic. Is that what? How'd you solve 2 sets? Was that not the proper way? That's just kind of like, I just found the pattern and I was like, okay, let's go ahead and try it. Yeah, greedy goes hard. I don't know why I originally thought to start from the smallest, but whatever. But I'm trying digital queries now. Start from the smallest. 1, 2, 3. Yeah, I don't know. I don't really care. I solved that problem. I'm done. I was scared of that problem for so long. This stream was a really good stream. I solved some pretty good problems. I'm not even gonna lie. In 2 hours, too, which is crazy. Today I popped off. Dude, do you think I'm gonna be able to get digital queries in the next like 20 minutes? I don't think I am, bro. I do not like this problem. Let me explain what I've been thinking so far, though. Birdie. It is like the number of digits, right? The number of like changes that you have to say. Okay, so for like this section, if there's 2 digits, right? The eventh number is whatever like I don't know. Chat's delayed, bro. Chat is delayed. I do not know. What are you saying this shit to? Okay, I see. Okay, I see. The hell knows to what? My solution or what you did? Oh, here's your 2 sets. Oh, your 2 sets code is so much cleaner than mine. Okay, to my thing? Okay. See, you know, hey, I'm gonna give you some life advice right now, okay? You do not let me cook. Let me cook for a little bit before you start yelling at me. Okay, at least let me cook for a little bit. Let me get my feet wet when I cook. Okay, so basically, at least for like the 2 digits, right? You have 2 digits. The odd or the eventh, like if your query is even, it's whatever like main digit you're at. It's whatever main digit you're at. So like if I'm between 10 and 19, if I enter like an even number, it's gonna always return 1 no matter what. If I'm between like 20 and 29, an even number is always gonna return 2, right? But the odd number is always gonna return some value. I don't know what yet. I've also realized that there's kind of like an index pattern to it. Like at least for the 2 digits ones, -1, -2, -3 would give you the actual what you should return. Like it's like an index. I don't know how to code it. I don't know if there's any relation, but I don't know. What I've also realized is that digit 1, digit 2, you can get the amount of changes that you're gonna have, like the distance between like one set to the other set is gonna be 2 to the power of how many, like 2, the number of digits basically, dn times 10, right? Because 10 changes can happen. So for 2 digits, it's gonna be 20 changes until you can like go to the next, until you know you're at the next value, right? And then once you're at the 3s, it's 3 times 10. So there's 300 changes until you go from 100 to 200. There's 300 changes at least in the middle. Like there's like a distance of 300 queries in between the two. And that's all I've coded so far. Yeah, can you because I don't I do not know what I'm doing, to be honest. I don't know. I feel like digital queries is gonna fuck me up, to be honest. Is there something involving mod? Or no, is that not close? Because I'm thinking this is a mod type of thing, but I don't know. Probably not. Because like the reason why I say that is because, well, 19 prints out. Not really, but the intuition's there. 4. If 20 changes need to happen. Because I feel like the idea behind this is like, I don't know if this works though, because like this range is so big, like 10 to the 18th. I'm like thinking like the goal is to kind of like shrink this thing down. Like your big query, shrink it all the way down until you can get to something in this range. Is that true or no? Like kind of like take this big K. Like this K or whatever. I'm not gonna say. Well, I'll just go fuck myself then. So if I had 19 goes to 14. Where's the 4? What does that mean? So if I'm... I know since this is kind of like even and odd, just has to be a number between 1 and 9. What? Mod it? I don't know what I would mod it by though if I was saying that, but like also like I don't know if you're responding to like me saying the calculate part. Is there like some just formula I should just plug in, or is there actually some like calculation, like a little bit of like simulation type stuff that I'm gonna have to do? Is that a valid hint I can ask for, or no? Or are you just gonna tell me no? Because I don't think any like even like just this, I don't know. I guess it doesn't matter, but like if it gets really big, well that could be like a log n if you divide it by something over and over and over again, like log 2. 10 to the power log can handle 8 log n can handle 10 to the 18th. Well, 19 divided by 2 is what? What's like that value? 9? 9 divided by 2 is what? 4? Did I just figure it out? I don't think I did. 20 divided by 2 is what? 10? 5? No, that's not working. Well, 20, I said 20 divided by 2 is 10. No, this is not working. Let's just have some random query called 15. I don't know what this equals to, but I know it's not even, so it has to be something. Let's divide it. That gives us 7. So 15 should be correlated to 7. Fifteen is 10, 11, 12, 13, 14, 15. No, that's 2. That is not close at all. Okay, so that didn't work. So the divide by 2 idea is not working. Because I was thinking you can divide by 2 until you get between the 0 and 9th range, but obviously that didn't work. So wait, if I take 7 minus 15, what do I get? What is that? 8, 9, 10, 11, 12, 13, 14, 15? 8, 9, 10, 11, 12, 13, 14, 15. That's 8. Negative 8. 15 minus 8 is going to be 7. I don't know why I just did that. That was stupid. That was dumb. That's going to be 7. That didn't change anything. How are we going to reduce this range? You can't mod it. And you can't divide by that. $19 divided by 2 is 8. can't like subtract. If I said 19 minus it by 20, you get -1. That doesn't help me at all. These drawings are making me go insane. What is this? You really think so? Do you think, like, do I have, like, the tool? Is there, like, some algorithm I'm supposed to know from this? Or is this just, like, that I don't know yet? Like, what is this? In, like, a month? Damn. A month is crazy, bruh. Alright, whatever. I'll come back to it. I feel like digital query is going to be like one of those problems I should just come back to for like every other day and just like think about it for a bit. That's like a long-term thinking problem. This is like a permutation type problem. Which one? Query strings or not query string? Yeah, query string. Query digits, right? Query digits or digit queries. What am I confused about? The whole problem. I don't know the solution, so I'm just gonna come back to it a little bit later. Creating strings I can do, but I really don't. I hate permutation problems or stuff that's similar to it, so I don't really want to do that. The way I'm thinking, okay, wait, actually, should I just solve this problem real quick? I think I should. Do you think I should solve this problem real quick? Because I only have a little bit of time left before I want to end stream. Okay, because what I'm thinking, alright, so here's my thought process. A, B, C, right? Oh, it's actually AC, right? Well, this is just a permutation. 1, 2, 3, 4, 5 of 5 long. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 0, 1, 2, 3, 4, right? Well, let me actually rewrite this as indexes. 0, 1, 2, 3, 4. Well, you can permute like this. 4. Like, you can do all this, right? Oh, wait. Oh, no. Does this have to be in a specific order? Oh, an alphabetical order? Oh, that's fine. It depends on what problem I'm solving. I'll use Python or C++. So this would be like 0, 1, 2, 3, 4, 3. This will be 0, 4, 3, 2. Right? That's how this permutation works. However you say it, the Lexi one or whatever. The Lexi permutation, this would be 0, 1, 4, 3, 2, right? Or am I tripping? Whatever. So you kind of like permute it like in this order, and then you'll get 1, 2, 3. Wait, what is this one? 2, 3. There would be 1, 0, 2, 3, 4. So you kind of like permute it in this order, and then you kind of just like Oh, well, it has to be in alphabetical order. So we could sort this in the alphabetical order. Because what I'm saying is these this index represents the index of this, like the original index of this, right? That's what a permutation is. But if we sort this in alphabetical order such that it's A, B, C, this is A, B, C. This would be A, C, B, and this would be A. What's the fourth one? C? No. This has to be the lexical though one. I think I just fucked it up. Did I fuck it up? Because it would be A, then B. This is CB. And then BAC. For it to be BAC, it would be could be. Wait, did I fuck up this pattern? That's my question. 1, 2, 3, 4. 1, 4, 3. I don't think I did. 0, 1, 4, 3, 2. The number 4 is 0, 1, 2, 3, 4. C though. C's not supposed to go yet. That's why I'm like kind of a little concerned, because I think I fucked this up. If I write my permutation, instead of like doing it in that order, what if I write my permutations? Swap. Swap. This is the right order, right? Or am I tripping? Am I stupid? You take this input, sort it in alphabetical order, A, B, C, and then just do a LEX or whatever permutation. Such that, because if you have it in decreasing order, such that the biggest, like, what is this? The biggest value, technically, would be C. So if anything behind C is decreasing, then it's okay. So A, B, C, A, C, B. That's not alphabetical order. It's just, this is alphabetical order. I think I'm overcomplicating this problem, and I just need to permute it. I think I'm just being dumb. I don't think that there's any, like... No, there has to be, because they have a permutation problem. So there has to be something more to this problem. They have a permutations problem. Let's just try. I think let's just full send the naive approach, which is just sort it and then permute it. And let's just hope that I didn't oversimplify this problem, and it's really just that simple. This code is so bad. Creating wait. These sort strings. C++. There has to be a function for it, right? Oh, you can't just say that. Sort s.begin s.end. There you go. Oops. Nice. What is up? What is up, everyone? Alright, now do while next permutation s. See out s. See what happens. Oh, okay. I said something wrong. Am I supposed to provide the length or something? N s dot size. Wait, how do I use the next permutation function? Does anyone know? S plus n? Okay, no, that did not work. How the fuck does the next permutation function work? Pull up the docs? No, bro. Never. Okay. Sort? +3. What is it? Why does it say +3? We have the algorithm. Give me this. Give me that. Give me that. Give me that. S plus n. No. You use the iterators apparently. Oh, shit. That makes sense. Okay. Don't see this out anymore. And then basically int count, sort count plus equals 1, vector string perms, perms dot pushback s cout count line 4. What the fuck? 4 I perms dot size x plus cout perms I. Alright, just say I. Oh. Okay, that should work, right? Everyone thinks it's gonna work. I think it's gonna work. Wait, actually, let me compare it to the test case before I just go and full send the submit. Okay, it works. I only compared the first 3, but it works. We're just gonna full send it. Where is this? What was the name of that problem? Creating strings. Easy peasy. Your boy's the GOAT. Realize you gotta sort it, permute it. Let's go. Damn, and dude, you know what's crazy? I was overcomplicating that problem. I was like, damn, do we gotta go to lexicon? No, bro. Just sort it, and then permute it. Alright. That's it. Don't overcomplicate shit. Don't overcomplicate shit. Yes, sir. Yes, sir. Alright, so, unfortunately, this is the 3-hour mark. This was a solid session. Last session, I got humbled. Because someone gave me a lot of number theory problems, okay? So, I'm going to recap the session. This is the end of the stream. Before, if anyone wants to leave now and they don't care about the recap, thanks for showing up. Thanks for everyone that came in the chat, watched me, supported me, and everything. Wait, what are the prereqs for that question? If you know how to sort and you know how to permute, then you can do this question. But, yeah, so thanks for everyone that came into the chat, hung out with me while I did these problems. And, yeah, so let's go over what, I guess we'll just go over what we did today. We actually achieved our goal in, like, last session. But, by the way, if you don't want any of these solutions spoiled to you, close your eyes. We did the daily, which we did in one try because, oh wait, no, this is not the daily, this was the other daily. We did reverse link lists. I mean, I don't even know why I'm showing this, but yeah, reverse link lists. Then we did combinations, which was like a warm-up backtracker problem, which was pretty cool. This was pretty easy. Felt good to do. Nice little warm-up. And then we went and we did minimum pass sum. So this question was a little bit annoying. We came up with the solution of like kind of like a Dijkstra's with a priority queue and everything, but it turns out it was a little too slow. My intuition though was kind of right at first, and then we found out it was too slow. And then I don't even know how I figured it out, but I figured out the pattern of doing it from the start and kind of doing a DP solution, which turned our whatever our code was runtime to O of n times m, which is way better. This is like a DP type solution, and it actually worked first try when I wrote it, which was pretty cool. This was pretty hype. This was a good problem. This was actually a good problem. I was a little nervous when I came at it at first. I was like, okay, I know I can solve this problem, but am I going to solve the problem? And we did, which is pretty sick. So, and by the way, all these were filmed on the live, so if you ever want to go back, watch my thought process, how I was doing the problem. I drew out everything, I was explaining everything as we went through the problem, so yeah. That's cool to watch. If you guys like watching that, we can see the submissions, we got TLE, and then we went back and we did the DP solution. And we got right in the middle too with the runtime, which is pretty nice. Then we did that. So then we went to CSCS. We did some problems in CSCS. We did the 2 sets problem, which I was scared of the 2 sets problem, but I finally figured out like the actual correct solution, which was the greedy approach. From the biggest to the smallest instead of the smallest to the biggest, which I'm pretty proud of because I did try this problem a while ago, like a week ago, and I was scared of it. I was like, dang, this thing's complicated, like what the hell, especially with this kind of runtime, like this is crazy. And to come back after solving all these other problems and just kind of solve it in like 5 minutes or something, I don't even know how long, I'm probably undershooting that, felt really good. This felt really good to solve. We didn't solve digit queries again, but that's okay. And then we went over to create strings, and then I realized that it was just a simple sort it and permute it, like instantly, which felt good to solve. Sorry to Jinx, who I kind of almost just spoiled the solution to you, but yeah. So this was good. I would feel like this is a good day. This was actually a really good practice. This is the best practice session and live stream of the whole series so far. This is definitely a really good stream, and I'm glad that everyone showed up. So I'm gonna head out now. Hope you guys all have the good rest of your days. Good luck in whatever you're pursuing. I wish you all the best and all your future grinding that you have. That sounded really bad, but all the work you put into everything. And I wish you the best of luck in everything. And I'll be here tomorrow around the same time. So, see you everyone.